Hello, my name is Nipun. I am a technical marketing engineer in the IoT business unit. And today I'm going to take you through a brief overview of Cisco's Catalyst SD-WAN solution, and specifically for industrial IoT networks. We want to cover a few things. The first is give you a quick recap on what SD-WAN is and why we use it. These little bit of an overview and architecture of the key components, and a small demo of how to onboard a device, specifically an industrial router, and they give you a view into the configuration options on the UI and some of the policies and ways we can configure a router. So, what is SD-WAN, right? So with the traditional WAN, we are used to having devices connected to a centralized data center. But with the advent of modern applications and an application-oriented world, we have changing business trends, right? And we are moving more data to the edge. And nowadays, like moving the user's traffic from branches to a data center and then back out to the specific edge or the cloud is not efficient. And it's more so expensive and not scalable. So the rapid digital transformation of these enterprises creates these new requirements where we have to segregate these into layers. So we want to create new requirements for security, cloud, and internet connectivity, specifically WAN management and application performance. So the Cisco SD-WAN is a wide area network overlay architecture that sits on top of traditional networking networks, and it's designed to meet the modern enterprise application needs. So the goal is for improving the traditional WAN design is connecting any location, a branch location, a remote work location, hybrid work, and in our case, industrial edges. So we want to be able to connect any location with any sort of transport. So our SD-WAN system should be transport agnostic. It should be able to handle multiple transports and multiple links. It should be able to provide security, end-to-end security over those links. And for any type of service, be it analytics, voice, and in our case, video monitoring or utility monitoring or control traffic that utilities require or in our industrial IoT networks require, those should be able to fit into the security model and should be catered to like any other service in the network. These should be done seamlessly in a single pane of glass without the need for additional tools and other management options. So all of the entire network able should be able to be managed in a single pane of glass with on both on-premise or cloud and hosted options. They should be multi-tenant. They should have advanced analytics capabilities that you can extract data from your network and gain insights into the performance and other aspects. So what does Cisco SD-WAN actually do best for industrial IoT networks? So really, there are a lot of capabilities in SD-WAN, and a lot of these are catering to multiple types of enterprise applications. But specifically for industrial IoT, we feel these are some of the key areas that will benefit our industrial IoT customers. The first one being application prioritization, right? So this is done seamlessly through a single policy in a fabric and controller-based environment. So you can specify the path priority for specific types of applications. So for example, if you have a video or surveillance type application, you want to prioritize high-speed links with low latency. So you can prioritize the internet link and keep the 4G LTE links as backups. You can, for other types of traffic that require periodic updates or smaller packet profiles, you can use lower cost links that don't require as much overhead or don't have or the traffic type doesn't need as doesn't is more resilient to other types of overhead. You can use specific links for that. So we can cater to specific types of traffic based on these specific links. We also provide secure segmentation. So as I mentioned, different types of traffics can be isolated in their own zone. They can be isolated to their own routing tables, their own VPN, their own networks. So there's no chance of cross-contamination. There's policies that can be put in place to route specific types of applications or specific types of applications over a network through a specific type of topology. And all of these policies are VPN aware in SD-WAN Manager, and not all VPNs have to be present everywhere. So you can set that up, you can customize that based on the needs of your organization. The final thing is ease of use and the automation capability of bringing up a edge device. So when you use SD-WAN, the user does not have to worry about uh, connections to the controller, connections between the WAN edges or the hub or the data centers. All of this is done with a few clicks in the GUI, and if the policies and configuration templates are applied across the entire network at scale. So this brings ease of use into the front and the limelight, and is one of the key tenets of the SD-WAN management system. So how do we achieve all of this? So the architecture is split into three layers for the SD-WAN manager. The management plane is the manager of the system. It's for configuration, policies, and administration of the system. The control plane handles all of the topology and policy for the control layer and the network routing layer in the network. And the data plane is where all of the forwarding takes place. So all of your edge devices, your Cisco routers are where would be sitting in the data plane. So we start with the Cisco Manager. It provides a single pane of glass for day 0, 1, and 2 operations. Some of its key functions include centralized provisioning, policies, templates, troubleshooting, and monitoring. It also provides the full software lifecycle management of the edge devices, and a programmable interface for third-party applications to be able to interface with the manager and glean information about the network. It is also used to extract performance statistics collected from the entire fabric through the analytics tool. And you can get that for deeper insights into your network conditions. For example, if you have network brownouts or if you have a degradation in network quality, you can learn of that through past performance and network performance in your system through the analytics tool. The validator is essentially the network orchestrator for device bring up and secure communications between the device components. So it basically facilitates the mutual discovery of the control and management elements of the solution. It leverages a zero trust certificate based model. It automatically also distributes the list of controllers and the manager to the WAN edge device as it's getting onboarded into the system. For situations where controllers or the manager system or any of these devices are behind a NATing agent, the validator will help define that by by specifying the public and private components of the NAT and advertising them to the network. The Cisco controllers handle the control plane functions of the SD-WAN fabric. The controllers facilitate fabric discovery by running the overlay management protocol between themselves and the WAN edge routers. Together with the WAN edge routers, controllers act as the distribution system for information pertinent to the data plane connectivity between the WAN edge routers. The information includes LAN side reachability, transport side IP addressing. In our case, any OT devices connected to the network behind the WAN edge routers, those can be advertised through the overlay management protocol and be advertised to other WAN edge routers as well for full end-to-end connectivity. Control policies are also act on control plane information by locally enforcing these are actually locally enforced on the controllers. And these control plane policies can implement service chaining and various types of topologies that influence the flow of traffic across the fabric. So the use of a centralized control plane basically reduces the control plane load associated with building large-scale IPsec networks. The controllers themselves provide high availability and resiliency, and are often deployed in geographically dispersed data centers to even further reduce likelihood of control plane failure. The WAN edge routers are the data plane elements of the Cisco fabric, SD-WAN fabric. They are essentially the where SD-WAN needs to forward traffic and needs to extend to. So basically, it's extending your fabric to places that need the network connectivity. And as mentioned earlier, the edge routers establish the control plane relationship with only the controller and not amongst themselves. So this is the whole idea of SD-WAN management and the segregation and separation of the layers of control, data, and management. And the data plane also is responsible for the application-aware routing policies that are pushed down through the controllers into the WAN edge routers, as well as alerts and events that are sent to the manager system for the single pane of glass operations. The WAN edge routers leverage standards-based OSPF and BGP routing protocols for learning reachability information and for brownfield integration for non-SD-WAN sites. For layer 2 redundant services, WAN edge routers implement first hop redundancy, which can operate on a per VLAN basis as well. These edge routers, including industrial routers, can be brought online with a full zero-touch deployment or by requiring administrative approval or through a bootstrap process that can be configured on the router and be deployed during startup. The WAN edge routers are also delivered in both physical and virtual form factors. Physical form factors are deployed as appliances at the edge or as industrial routers or specific routers. The controllers can be deployed as an on-premise deployment or a Cisco or customer-hosted cloud environment. These are essentially virtual machines that can be deployed on top of a hypervisor. There are two main modes in the Catalyst SD-WAN manager. So the first mode is the traditional mode where we have the segregation of the orchestration, management, and control planes that help build the connectivity fabric. The second mode is the SD routing mode, which helps that simplifies the deployment and removes the controller piece from the system and provides direct connectivity from the edge devices to the SD-WAN manager. So in the SD-WAN mode, the traditional SD-WAN controller fabric mode, there are a few key components. So we have the controller that's talking to the SD-WAN manager over a secure DTLS connection. We have the transport side, which is your global routing or a global routing table and fabric, which is always on VPN 0. It's the overlay over basically the underlay WAN network. So it's transport agnostic and it can work over any type of transport. And this is where the overlay management protocol comes into play, providing fabric routing and connectivity. From a data perspective, we have the TLOC, which is the IP address of the fabric, and it helps form data tunnel connectivity between the WAN edges. It consists of a system IP, color, and data plane encapsulation. In this case, it's IPsec, and tells all of the routers in the fabric on how to reach the other router in the network. These TLOCs are advertised by the controller, and routers never directly advertise the TLOCs to each other. Rather, they advertise the TLOCs to the controller, and the controller reflects them to the entire network. The service side is the southbound connectivity or the interface attaching to the OT network in our case. In our case, it is the service network where your IoT devices or users will connect. And this is where we define the concept of VPN segregation and segmentation. And this is where we can define the number of segments to connect, the types of traffic that we want to isolate, and the types of traffic that we want to advertise into the fabric using the OMP protocol. All of this is managed via the SD-WAN manager GUI. All of the policies, the control plane policies, the data plane policies, the network router configurations and firmware, all of that is managed through a single pane of glass using the Catalyst SD-WAN manager. In the Cisco SD routing mode, we still have the concept of a SD-WAN manager. We have the transport side, which connects again directly to the SD-WAN manager through a secure DTLS connection. We have a service side interface, which connects again to the OT devices or the IoT network. We can also segment and provide secure segmentation for specific types of traffic here. And as I mentioned before, we manage all of this directly through the SD-WAN manager through a secure DTLS connection using a netconf management paradigm. And the key things to note here is there is no overlay, there is no overlay management protocol or fabric discovery or creation here. There is no separation of control and data components in this mode. This mode is purely focused on device management, centralized device management, and the router handles both the control and data functions in this mode. So let's go into the onboarding and demo pieces. So there are multiple ways we can onboard an industrial router into SD-WAN. Today we will be using the zero-touch PNP provisioning model, which is the most convenient way for customers to onboard devices. We want to start by adding the device to a PNP smart account. And we can either resync the Catalyst SD-WAN manager to the smart account through the GUI, or we can upload the inventory file we retrieve from the PNP smart account. We will be doing the latter. We will be uploading a inventory file that we retrieve from the PNP smart account. We will be then configuring a template for specific devices and specific features. Keep in mind, we will be using both modes. So we will be starting with the fabric mode where we define the VPN0 transport configuration template and the service template. And then we will also attach the respective industrial routers. In this case, we will be onboarding a industrial router 1835 for this demo. And then once we power on the router, we will check for the connectivity and look at the process, follow along as the router comes online and starts talking to the controller and manager. So this is the device that we will be onboarding. We will use a cellular connection to onboard the device, a cellular LTE connection to be specific. So to prepare, all we need to do is insert the SIM from your provider into the cellular modem and insert it back into the IR. And once we configure SD-WAN and the manager options, we will then power on the IR and wait for the router to come online and join the network. In the next series, we will show you how to configure the SD-WAN manager options and also walk you through as the router comes online in the system. Thank you.